Imagine baking a cake. You carefully follow the recipe. You measure each ingredient precisely. Flour, sugar, butter, everything is exact. This precision is key to a delicious cake. Too much flour and it's dry. Too little sugar and it's bland. Precision in baking, as in many things, leads to desirable outcomes. Precision is not just about baking. It's about making accurate and reliable measurements. It's about understanding the subtle differences between similar things. Whether we're talking teaspoons of sugar or nanometers in a computer chip, precision matters. Accuracy and precision are often used interchangeably, but they are distinct. Accuracy refers to how close a measurement is to the true value. Think of hitting a bullseye. Precision, however, refers to how close repeated measurements are to each other. You could hit the same spot on the target board repeatedly, but if that spot isn't the bullseye, your shots are precise but not accurate. Both are crucial in scientific endeavors and everyday life. A doctor needs an accurate diagnosis and precise drug dosage for effective treatment. An engineer relies on accurate calculations and precise measurements to build safe and reliable structures. Imagine trying to build a house without a common language for length. Chaos would ensue. Units of measurement provide this language for the scientific world and beyond. They give us a standardized way to express quantities. The International System of Units, SI, with units like meters, kilograms, and seconds, ensures global consistency. These units allow scientists worldwide to share data and collaborate seamlessly. They eliminate confusion and ambiguity, enabling groundbreaking discoveries. From the smallest atoms to the vastness of space, units of measurement are fundamental to our understanding of the universe. Imagine a scale that consistently shows your weight as 10 pounds lighter. While flattering, it's not very helpful. Calibration ensures that measuring instruments provide accurate readings. It involves comparing an instrument's output to a known standard and adjusting it accordingly. Regular calibration is crucial for maintaining accuracy. Medical devices, for instance, undergo rigorous calibration to guarantee patient safety. Similarly, scientific instruments rely on calibration to produce reliable data. Without it, our measurements would be meaningless, jeopardizing research and innovation. Section 5. Error Analysis. Embracing the imperfect. No measurement is perfect. There will always be some degree of uncertainty. Error analysis helps us quantify and understand these uncertainties. It involves identifying potential sources of error, estimating their magnitude, and determining their impact on the final result. Error analysis is essential for interpreting scientific data objectively. It allows us to determine the level of confidence we can have in our measurements. By acknowledging and quantifying uncertainties, we strengthen the validity of our conclusions and pave the way for further investigation. Section 6. Precision in action, from medicine to the stars. High-precision measurements are ubiquitous, underpinning countless fields. In medicine, they enable early disease detection, targeted drug delivery, and minimally invasive surgery. Advanced imaging techniques relying on precise measurements allow doctors to visualize the human body with unprecedented detail. In space exploration, precision is paramount. Spacecraft trajectories must be calculated with extreme accuracy to ensure successful missions. Telescopes, equipped with high-precision mirrors, peer deep into the cosmos, unraveling the mysteries of the universe. From the mundane to the extraordinary, precision shapes our world. Section 7. The future of precision, pushing the limits. The pursuit of ever-increasing precision drives technological advancement. Scientists and engineers constantly develop new tools and techniques to push the boundaries of measurement. Nanotechnology, for instance, operates at the atomic scale, demanding unprecedented precision. As we strive for greater precision, we unlock new possibilities. Quantum computing, with its potential to revolutionize fields like medicine and materials science, hinges on the ability to control and manipulate particles at the quantum level. The future of precision holds immense promise for scientific breakthroughs and technological marvels. Section 8. Conclusion. The enduring impact of precision. From the humble act of baking a cake to the complexities of space exploration, high-precision measurements are indispensable. They underpin our understanding of the world and empower us to shape it in remarkable ways. Accuracy, units of measurement, calibration, and error analysis are cornerstones of this pursuit. As we continue to refine our ability to measure the world around us, we open doors to new discoveries and innovations. High-precision measurements are not merely tools of science and engineering. They are testaments to human ingenuity and our insatiable curiosity.